But when we think of where aluminum resides inside of the brain, it typically goes to a lot of the glial cells, which we know are the immune cells in the brain. They do kind of go inside the neurons as well. And usually things like the cortex, the hippocampus, the cerebellum, and the amygdala in human studies are shown to be kind of some of the areas of highest concentration. Especially when we think of neurodegeneration, the hippocampus being a big one. A major reason, it's not quite inside the blood-brain barrier like a lot of the rest of the brain is. The hippocampus is more exposed to a lot of the stuff in the blood, unfortunately, which is meant by design, so then we can remember the stress faster and things like that, because that's what the hippocampus is designed to do. But it starts to go out the window. I wanted to talk a little bit about what's called pharmacokinetics of aluminum, just inside of a cell, what happens, how does it happen, things like that. Fun fact that I actually learned a few days ago while I was prepping for this, because I was like, well, I know aluminum, but let me learn it even better for this. Aluminum binds to ATP 107 times stronger than magnesium, because magnesium is required to take ATP and activate it, make it ADP plus P, right? Then we have adenosine diphosphate and we kick off the phosphate molecule. So aluminum can definitely kind of shut that down really strongly, because I was trying to think of like, what's 107 times stronger than a human? And I thought, well, maybe an ant a human size, or it'd be like maybe my toddler trying to fight Dwayne Johnson or something like that. He's probably about 100 times stronger than a toddler, right? But think of how mismatched that fight would be. So especially when you think of ATP, like when we think of it as energy, ATP is meant to heal, grow, repair, and detox. It's not really like energy like running around the block. We use it for that, but on a cellular level, ATP is real big. ATP also downregulates what's called G6PD, how we start to utilize sugar for energy, which is a big deal, especially like when we think of Alzheimer's. We know that's called type 3 diabetes in some research articles, because we just know that insulin, we even talked about it on some of the previous stuff we've done, like those advanced glycated end products, the receptor sites like RAGE and stuff like that. So, but then as G6PD goes down, guess what gets released more? More iron, more oxidative stress, more Fenton reactions, things like that. Aluminum will increase what's called lipid peroxidation, cell walls rusting, basically, lipids oxidizing, which is especially important because when we think of the brain, it's like 60% fat by weight, something like that. And that's what APOE measures. When we think of an APOE like a 404, those are a lot of cholesterol binding, like how does cholesterol respond to an inflammatory event like head injury or something like that. I think of aluminum kind of like a chemical head injury. We'll see all the same inflammation, all the same excitation that we will when somebody bonks their head. It's just chemically, it kind of goes down instead of like a physical,